Hi, Shubham. Good morning.
Hi, Vatsal. Good morning. And a very good morning to all of our participants here.
Right. So I think we can wait for a few more minutes.
So I think everyone will just be waiting for a couple of more minutes for people to join in, and then we will be getting started. Vatsal, while people are joining in, you know, this is about deep dive with containers and DevOps. So I just have a question for you. Like, how did you start your journey onto containers? What was your first experience with containers? How did you
Actually,
get
actually,
exposed to
our thought process works same. I was about to start this session with the same question by asking you.
Good thing we did not plan this ahead of starting. This is a
Right.
one that I thought of.
So if I will talk about it, I think I do remember when I have joined Red Hat in 2016, and in September or something, we traveled to Vietnam, and there was a technical exchange. So that's where I was completely unaware about what container is. I have never heard that particular technology, and suddenly I think I was with Rajat only. And what we did is we randomly just went into the session that let's see what is going on, what is container. And that's how I have seen the first time Scott was talking about the containers and internals of containers and all. And then I just thought that, okay, we used to fight a lot in order to run the web servers. But this is very simple, right? We can just execute one command and everything is up and running. So this is interesting. And then from 2017, and I think I have started completely my work with container and OpenShift and all of this. How about you?
My exposure with containers was around 2017, but it was fairly in while I was in college. There's an institute in Jaipur, and I was going there for my Linux studies, and that's where they came up with a course. Like they were able to sell it in such a way which was so fascinating that you can start your own OS in 1 second, and I was like, that is pretty cool. And I did not know what the reason was for containers, what problem they were solving. But for me, it was the way it was sold was so cool to just have a look at it.
Mhm.
And that was my first experience with trying to work with containers. And when we did like, Docker run, go inside that container, and then you read the host file or etc OS release file, which is completely different from your OS. That was pretty cool.
Right.
That was my interaction with how it has been with containers.
Right. I also do remember our first certification on the container world, that 270 and 276.
Oh, right. That's a pretty old time we're talking
Yeah,
about.
I'm an old guy.
That's quite old. I remember when I came to know about these certifications, the 276 was going away. It was fading out by then, and 280 was the one which was replacing it.
Hmm.
DO 280. That was also way back in version 3.5 of
Right.
OpenShift, the platform. Now I think we have 4.11 generally available, but
Right.
before it was 3.5, and that's where I got to get started with it.
So basically, we are the kind of a people who have seen the containers and Kubernetes and specifically OpenShift grown up, right? Because I do remember when I have appeared my first exam on OpenShift, there was some sort of ISO that you need to mount, and then you are installing the entire OpenShift manually, and it was pain.
Oh boy.
And there is a very simple dashboard. There is nothing much you can do. And now if you look at the OpenShift graphical console, at least you require 2 to 3 days to understand what exactly all the available options are there.
Right. I think the reason why, or it has always been the case, OpenShift was always more focused towards the developer to make their lives easy on how they can, onboard their applications, and they could start and they could fasten the build and deployment process altogether, giving the developer more control on the ops side of things. Being an enabler of DevOps is what OpenShift brings to the table. But now if you look onto it, it has a complete administration profile perspective that I think, which is very, very interesting. You can add more compute nodes. You can just change your network configurations directly from the console. I mean, still there are some things which are lacking, but we have come a pretty long way from only thinking about a developer to all the way from here.
And whomsoever who has brought up with this such idea, I'm sure he must be a manager, because manager is the one who know the fight between developer and admin. So he must be frustrated and came up with this solution.
They must be like, hey, you know what? I have done all my changes. It's not my problem anymore.
Right.
Push it to the testing environment.
I think you have that image as well, right? This is not my problem, and that was nice image.
Yeah. There are so many memes around containers these days, tech memes, which will be made by a lot of people, and we can just go to Google and search for a couple of them.
I used to use that container went to the bar wala jo image hai na.
Oh right. Yeah.
The different layer one.
I think I have an image problem.
Yes.
One container says to the other. Yeah.
Right.
My manager thinks I have an image problem.
Okay.
So I think we can get started.
Yes, Snigdha.
Yes,
Vatsal. Shall we start?
No. All right.
Okay, perfect. So let's start with the introduction. And first of all, thank you, everyone. It's maybe you guys are already into the Diwali and festive mode, and still you managed to join, and that is really appreciated. Thank you, and welcome to this Container and DevOps webinar. So my name is Vatsal Thakor, and I have been working with Prodivance as an associate director, and I'm basically taking care of two different verticals. One is the product delivery, as well as I'm taking care of the training delivery related to the corporate and retails and all. So we are going to discuss in a much detail about the containers and DevOps, and also we are going to share certain follow-up plans based on this particular session, right? So yeah, Shubham, over to you.
Okay. Hi, everyone. Good morning. And as Vatsal said, thanks for taking off your time from these festivities. I know the Shera and Diwali are coming up, and we IT people always look forward to it because no more work in these times, at least for some of us who are lucky enough to get that. So thanks for joining in. And I am working as a senior site reliability engineer at Prodivance Technologies. Before that, I used to work as a Red Hat examiner and an instructor across our customers in Europe, Middle East, and Africa. And now I'm working with one of the leading banks in Europe and one of the leading pharmaceutical companies, working on Ansible and on day-to-day operations on Kubernetes and OpenShift on top of that. So that's a bit about me. And I do love containers quite a lot. So that's just some of the things.
Right. Next slide, please, Snigdha. Okay. So as part of this particular webinar, we are going to talk about a lot of things around the containers and DevOps. So if you look at this agenda, we will talk about what exactly the containers are, what is the runtime, why we should go ahead with the containers. Also, we will talk about certain problem that is occurred with if you are going with the plain container world. And based on that, we will come up with the kind of a solution where we have an orchestration layer, which we are generally putting on top of the container. So what are the number of different orchestration options we have, how we can go ahead and use that. And as we know that one of the market player is now OpenShift. So what OpenShift is a little bit, we will touch upon that particular discussion as well. And also we will talk about why we should go ahead with the OpenShift. And then another very important part of this webinar is basically when the containers and the OpenShift come on the same stage, obviously there are certain things which is additionally get added on top of this particular entire structure, which is your DevOps, where a lot of process in place are available. So we will also talk about what exactly the DevOps culture is. Also, we will talk about what kind of a number of different benefits generally we are getting it by using this DevOps. And also, we will see how exactly this DevOps is going to making your journey in terms of moving from your current workload to the container world, how exactly it is helping us and how it is making our life easy. That's what we are going to see. And then we are going to see a few of the magical demo done by the Shubham, where Shubham is going to show some of the unique features of the OpenShift environment, and then we will move to the questions. So I think that is what the main agenda of this session. Next slide, please. Okay, so the first discussion which we are going to do is what are the Linux containers? So again, if you go to any of the organization now, containers are basically become a kind of a minimum requirement, we can say, because I remember when I have started my IT journey in 2015 or 16, there was a minimum requirement that you should know the Linux. But now if you are planning to appear for any interview, make sure that you know the container, because there is somewhere container or somewhere DevOps or somewhere this Kubernetes word will be always and always there. So what exactly those containers are? So in a simpler way, we can say that containers is in kind of a way where we are going to pack our application and required libraries into the one specific box, and we are pushing it to the specific registry. And as and when required, we will pull that boxes and then we will create the container on top of it. That's what the Linux containers are. So let's see what Shubham is thinking about the containers.
I usually have a very stupid idea of what a container is, and that works pretty well for me. So take an example, when you're working with let's say you're working on a shipping company, all right, and you have to ship a mango from US to Mumbai all the way through the route of the sea. Just a very simple example. You want to ship a mango from US coast somewhere to Mumbai through the sea route, and for a mango to be working fine, or for it to be in a good shape, it requires a certain amount of humidity. It requires a certain amount of temperature, certain amount of sunlight. Let's take for example. And what will happen if I just put one mango on a ship and the ship is going all the way? Let's say it takes 24 hours to reach Mumbai. That mango is going to get bad. It's not going to be good. So what we want is, we want to have that mango shipped from anywhere to anywhere, but that mango should be in its right state. And so we get the right fruit. If you take this terminology, if you take this analogy to containers world, what would you do for saving that mango? First off, what if I have a box, I put the mango into it, I put the AC in that box as well, which has the right temperature. I also put a humidifier into that, which is making sure the right humidity is also available. I make sure that enough sunlight is coming up, not less, not too much. If I make sure all of that, then it doesn't matter where within that journey my mango is, because it is in a box which is isolated from outside. There may be 50 degrees outside, but my mango is on 15 degrees. Because my box is isolating every of those resources or those differences of the environment. And once I get into Mumbai, I get my mango. This is exactly what happens in containers. When we say we are packaging applications, previously what used to happen, say if I'm a developer, I would code something, I would put it to GitHub repository, and some tester will take it from there. The problem that happens in this case is, say I'm a developer and I always like the latest configuration. So I might be writing a Java application. I install the latest version of Java. I install the latest version of JDK, latest everything, because I want to keep up with what's being going on as a developer. But in production, we don't always go for the latest versions. We always go for what is stable at that point of time. So if, let's say, Vatsal, if I write some code and I have a function which is only available in that latest version of Java, you take my code for testing. And because you are the last line of defense, you are the one who will be approving if it's okay, it will go to production. So your stakes are very high. You have to make sure you catch all the problems before it makes to production. So testers, they more focus on reliability. They more focus on stability. So he might be using an older version of Java, which is stable. I was using a newer version of Java, which was, which was latest. I had a new function into it. And when you are going to run this on your system, Vatsal, it will be failing because you don't have the right function because your version is different. Then you'll come back to me and say, hey, you know what? There's a problem in this code, fix it. You might have 20 different other codes to also, test. So you might not be able to give me exact problem, what was happening. And this is happening in the real world as well. I will go on my code, I will run it on my laptop. And because my laptop has the right version for which that code was written, I will say it was okay. I never had to change it. It's not failing. I'll push it back to you. So it's like throwing over the wall. And I'm not aware of what's happening in the other background. This was changed in 2006 when Amazon CTO, they said to the developers, you build it, you push it. That's where the whole DevOps thing came into the picture. So it's like, I'm not just shipping my code, I'm giving you my laptop as it is. My laptop has the right version for this application to run. My laptop has the right configuration files and configurations for this application to work. That's what's packaging the application. So you have the box, which has humidity, humidifier, which has AC, and the Mango. So the Mango is your application. Humidifier and those AC are like your, you can think of them as your dependencies, libraries, runtime environments. So your application is isolated from these environmental differences. So that's how I think of what a container is. And the very good thing that has happened so far is portability.
Right.
We are moving a particular container. I want to ask this question to all these attendees, and guys, think about it. If you want to work with Notepad for 2 minutes only, just for 2 minutes, you want to work with Notepad, you don't have a Windows system, what do? We install Windows, right? And we all know how much time it takes for a Windows to be installed. At least 30 minutes. And how much resources are you giving for that Windows instance? You're giving 4 gigabytes of memory. You're giving 4 CPU, 50 gigabytes of hard disk, or 30, 40, 50, depends upon what is the recommended and the minimum. Only for being able to work with an application, only for 2 minutes that you're going to spend with it, you had to wait so much time and you had to give so much resources. That just doesn't sit well, and that is what Vatsal, I think containers are trying to get away from. We are saying they're lightweight because now think about a Windows operating system, which has only the bare minimum requirements and Notepad. It doesn't have Windows Media Player. It doesn't have Windows Photo Viewer. It doesn't have Windows Evernote. It doesn't have those smaller games that you get. You don't need them. So stripping out on those non-required applications, that makes it very, very lightweight, and transferring over the network is extremely fast compared to a 4.5 gigabytes or 9 gigabytes of ISO, which is for a complete OS. So that's how I perceive containers as an idea.
Right. And we have also seen, the operating system or basically the way we are running our workload, that is drastically changed, right? We used to deploy, whether it is Windows or Linux, 8-9 gigs of operating system, deploy that, and then put your application and configure your libraries and everything we are doing, right? Now what we can do is we can just simply pull a one image, which is hardly coming with a 600 to 700 MB maximum, and then we are able to easily run our application, right? So that is again, we are able to save a lot of memories, a lot of CPUs, right? So that is a nice benefit, right? So again, Shubham, I'm also a big fan of mango, even though I have a lot of mango trees at my home, but I'm crazy about mango. If I will ask you the next question, next slide, please, Nigda. So how do you basically explain runtime?
Okay. So there is
In that
quite a
same
bit,
example where you're talking about the AC and all.
right? I'll try that. How do you define the runtime? See, I think there is a pretty gray area between what is a runtime, what is a container engine, what is Docker itself. And there are tons of documentations over the internet, which has actually not helped much, but caused a lot of problem because everybody is writing upon their own experiences, their own words, and people will get confused about it. And that's similar what I'm going to do. I'm going to explain from my understanding and my experiences. Container runtime is something that creates that container for you. And when we say creates a container for you, that we need to understand the internals of a container. What is needed for a container to be working? You know, I might not take that as a example of the mango, but say you're making a house, all right? You're making one room into it. Within that room, you need to have electricity connection. Let's say the essentials, not the sofa, the TV, not that. But when you are making a room, you require some electrical connections. Okay, you require plumbing to be done. So you have, water in whichever area you want in that room. So there's water. You also require that there's proper ventilation being done. So you as a user can live in that. You want the water, you have it. You need sunlight, there it is. You need electricity, it's right there. You have the switches that you can use to turn it on and off. You use it according to your requirements. And every other room is going to be like that. An ideal room, the MVP, the minimum viable product, that's the room with these three requirements: electricity, water, sunlight. So you have a way to live in that room, and you are the one who's going to live it. So the person who's making this room, he knows about how to work with electrical equipment. He knows how to work with the wiring in that particular room. He knows how to work with switches, panels. He knows how to work with plumbing as well. He knows how to fit some pipes. He knows how to turn on and off, and what will happen when I turn off and on a tap. He knows how to put the windows into that wall. So that person who's making this room with these requirements, that is a runtime in a container level. That's what I call a runtime. So a container runtime is the one that is responsible for creating the bare minimums required for a container, such as working with namespaces, so that I, as a user, I only run Docker run command. I can't do anything more than that. So a container runtime is responsible for creating the namespaces, handling all those namespaces, making sure that application can access those namespaces. See, it will also be a problem in Vatsal. If you have a room, you go in that room, there are wires in this, there are wires in this wall. But if there's no socket that you can connect to, it's not going to be of any use, right? So they also make sure you are able to connect to those resources. So container runtime is responsible for letting your application use those namespaces, such as port numbers, PID tables, and all the resources. There's also they handle managing the storage for us, because containers will be writing some. In the end, it's just an application. An application might require some logs to be written. It might need some config files to be stored. And that is what a container runtime also handles for us. It manages the volumes that a container can use. It manages it manages how much can you use out of the infinite pool of resources that you have. Especially when you go to, I think a very good example of that is an airplane, which has first class, business class, and then economy, premium economy. As a user, if I am in an economy seat, I can go to the washroom in the flight, and I can just come back to my seat. But if somebody is in the first class, they might have their premium bathroom completely in that airplane. Etihad allows that, if you see it.
Right.
So because they have paid more for it. So there is only enough amount of water on that flight, but let's say 1 liter of water is given to the people who are in economy class, but 10 liters of water is given, hot water is given to people who are in first class. So they are doing a controlling of resources based on how much somebody has paid onto it. For instance, the more you pay, the more you get. That's always the case. All right. So container runtime is also someone who lets you control how much resources can one application or one container be using. So the other application doesn't end up hungry because one application was written poorly. There may have been a memory leak that's coming up. Memory leak is something which happens when an application has asked for memory, but it is not.
Are you referring to the Java applications?
No offense to Java. But yes, it happens. Okay. So that's where C group can be helpful. And all of this is managed by the runtime, which happens to be run C, for example, that we are using.
Right.
So that is how I see as a runtime. Many other things such as SC Linux and that's written on the screen. It's anyway. That is what a runtime lets you do.
So a lot of time, what happened? People are still living in a kind of a misconception where what is container? Container is basically created by the Docker or Podman or Rocket. And that's where again coming back to the spot statement, internet is wrong, and that is true, right? Container is just we always see that blue line which is staying on top of the operating system, and then there are containers, right? But that blue line doesn't do anything actually. That will basically providing kind of a easiness in order to creation of container and all, right? So as a user, as you said, we just execute the podman run command, and what will happen in the backend is that blue line will talk to the entire again operating system, and it will use the standard Linux functions in order to create the container, right? So yeah, that's what exactly the run C is doing. Next slide, please. So when we talk about the containers, again, we have seen that how exactly the things has been changed, right? We used to, whether we are using a bare metal machines or we are using the virtualization or whatever it is, right? So we used to always put the operating system overhead on top of those bare metal or the virtual machines on top of the hypervisors, right? But the idea was very, very simple, right? But how to implement that, nobody was know. And we have struggled a lot, right? When we are deploying our application, we need to deploy the entire operating system, which is not required, as we discussed earlier, right? So why to install those calculator and other applications, which is completely useless in order to run my application? So why it is there? And that's where these containers are coming into the picture, where what we can do is we can simply deploy our operating system and put one additional layer on top of it, which is maybe whether it is Podman or Podman or container, Docker, or maybe some other Rocket or kind of a solution, and which will basically make our life very easy in terms of running the containers. Plus, the another benefit we can say, it's completely independent and isolated. So even I can run one container with a Ubuntu, another with the something else. Maybe I can run 100 different operating system in each one of the containers on top of the same host, right? That is again a really nice benefit. Plus, if we look at again, as I was talking about, the sizing of those particular image. So as they are very lightweight compared to virtual machines, obviously we can able to run more applications, and we can utilize our resources in a very well manner. So that kind of benefits are really awesome, which is coming from this container world. Next slide, please. Right. So container has given a lot of benefit, right? And everybody started liking the container, and there was a specific time of 1.5 years where everybody want to move to the containers, right? Even they don't know anything about the containers, still they wanted to move their organization or their workload on top of the container. But at that time, there are a lot of people who was not aware of the problems, right?
I think that's probably because a lot of recruiters were looking for people who has containers in their resume.
Right, right. Shubham, would you like to talk about this problem statement?
Sure, yeah. The problem is too many containers. That's it, in one word. Too many containers are there. And when we talk about a replication, when we talk about a particular service, let's say Netflix, for instance. We'll take a use case of Netflix for example, all right? So Netflix is not one single application. I mean, it depends upon what perspective we are looking from. For me, it's a one single app. I go to Google Play, click on install, I get Netflix, give my username and password, buy some subscription, and I get the access. That's one app for me. But what is happening behind the hood for handling 200,000 or more than users, DAU or MAU, which is the daily active users and monthly active users, on that scale, with their resiliency, it is not just one server in the world cannot handle that all. That is where they are scaling out. Scaling up is a way to add more resources, get a bigger guy, and it will do all the things for you. The problem is there's a single point of failure. And that is where we talk about scale out applications. So we have more servers and we put one copy of the application on all the servers. I think everybody in our attendees will know about what is scale up and scale out is. The problem that happens with breaking applications down, for instance, Netflix, it might have one service for database. It might have one service for front-end application, the UI that we see. It may have one service which sends us push notifications on our mobile that you have a news show coming up you might like. There may be one service which tracks our history, and these services will talk to each other. There may be one service which is like notification service that, you know what, I saw in the history that you were watching this same kind of content is this. I'm suggesting you this. So notification service and suggestion service also could work together. Suggestion service will say, okay, I talked to history. This is what the user like. I want you notification to tell him we have this sort of content. So they always are constantly talking to each other over the different protocols in our network. All right. With that level of distribution that we have, with millions of users, we can't have 1, 2, 3, 4, 10 or 100 containers for even one service. Keep in mind, just one service. All right. When this becomes bigger, you have a problem of making sure if on that particular node, that application's container number 97 was working or not. And if it is failing, you have to replace that as soon as possible because your customers are paying you money for it. And if they are not getting the content, trust me, how many OTT platforms we have? Many, right? If for 10 seconds, my mobile is not able to, or Netflix is not able to play a content, I'll go to Hotstar. If a Hotstar is not able to play, 10 seconds I'm just talking about. So a user wants so quick expectations and results, and they have high level of SLA. An end user might not even know what an SLA is, but they're already into that category. They want it as fast as possible. And especially with these cutthroat competitions with other OTTs, to be ahead in the game, they need to be able to scale up and scale down. See what happened with the recent match that happened with India, and I think it was New Zealand. Unfortunately, we lost that, but 1.5 crore people, or I think it was 1.5 or 10 crores of people, I don't know, but it was a pretty big number. Many people were watching that concurrently. It's not the number that is big, that is fascinating, but concurrent number of users, that is where things go wrong. Flipkart, every big billion day, it goes down. We have seen that, right? So they still have issues with it. And Flipkart is a very big company.
True.
Adopting, being able to scale up and scale down on those many instances, and everybody should be able to connect with each other. So whenever a request comes to any random instance of, let's say, my front end should be able to talk to the database. And every front end should be able to talk to the database. And we know that databases are pretty heavy in terms of reads and write. So that network configuration, that latency problem happens when you're using one single host. And in a distributed environment, if you have, container number 57 dying, if you don't know about it because you don't regularly check them all, you will be in a problem that you cannot get away from. Randomly, you will get a call from someone that, you know what, we're having some issues. Okay, I have hundreds and hundreds of servers. What is a some issue? Where is it? On what application is it? Why is that happening? Is it because of some other problem? Is it because of an API that we were using external that is not available? We don't know that. So we need to know these lower level details, monitoring and observability.
Right.
You know, that is
And
important.
a lot of manual processes there when involved with a plain container world, right? Which is not a good idea. We as a human, we tend to make mistakes, right? And if it is all manual, then it is pretty hard to manage such huge workload. And also we can see that when we are trying to scale up and scale down these applications, obviously, if it is not a microservice architecture, then we are unnecessarily scaling up all the resources, which is even not required, right? So again, microservices has played a very major role in terms of adoption of the container, we can say. So these are the kind of problems which we have seen with the containers. So what is orchestration then? What do you think about orchestration? Why it is changing our lives? And again, you can maybe go ahead and speak about the OpenShift, which is your favorite topic.
I think before we talk about orchestration, I would want to continue what you were saying, that microservice architecture is better because if it was a monolithic application, if I want more instances of a database, and if the database and front end are running on the same server, I create the replica of that server. I will then have one more front end, which I do not want. I only want the database to scale up. That problem is solved. True. But I think this microservice architecture is a reason of why we need some sort of orchestration. Because you have, see, if front end wants to talk to backend database, I can just give the connection string, username, password, and localhost, because they're running on the same server. The problem that happens when the moment we break it down, I have one server which is running database, one server which is running my front end. They don't know each other yet. Where are they? How do I tell my front end to reach this IP address for the backend? I do not know that. And that is a problem that happens with microservices. The discovery of where your peer applications are living, that becomes very, very challenging. Especially the problem is if let's say your database number one goes down, database server goes down, you can get a new one. But what if the IP of the new one is changing? Your front end is still calling the old IP address. And that is still a problem. There's a connection, there's a connection which has been broken. So when we are working on that scale, automatic managing of applications, rolling out, if something goes back, roll back to a previous version, being able to deploy that in a microservices environment, being able to do service discovery, which we just talked about the problem, that is what an orchestrator is. It lets you take away all those pain and handles it for you. So you as a user only works or only thinks about the productivity, how to get the new version of the application, keeping the routing decisions, networking decisions, storage decisions, memory management, the limit and on the CPU and memory, all on the cluster or on the orchestrator platform itself, which happens to be Docker Swarm. We have now, which everybody puts in their resumes, with the first line, Kubernetes. Kubernetes was so popular that a lot of CNCF certified distributions have came off of it. There has been Red Hat OpenShift container platform. There has been VMware Tanzu Kubernetes Grid. There has been Rancher Kubernetes Engine. There has been Kubernetic, for instance, and so many more. There are certified distributions of Kubernetes. Everyone is giving some additional features over the vanilla Kubernetes, which is the orchestrator. And so does OpenShift, I think. It allows it easier for developers to get their applications on board. OpenShift is more developer focused. That's what I think.
Snigdha, next slide, please. One more next, please. Yeah, sorry, Shubham. You can continue. You're talking about OpenShift.
Right. We were talking about, I was talking about OpenShift, and OpenShift is built on top of Kubernetes. So when I was starting to understand, I think my journey with orchestration has been a little strange. Reason being, people will first learn Kubernetes and then they will go to a certified distribution. The benefits that they are giving on the table. But for me, I learned OpenShift first, and then I went back to learning Kubernetes. And I was like, I've seen this somewhere.
Same for me.
It's because coming from the Red Hat background, we had access to OpenShift pretty easily. So when I went back to Kubernetes, I thought I already have seen this. I know what a deployment is. I know what a pod is. I know what a service is. I know what SCCs are. But hey, Kubernetes does not have a build config. Kubernetes does not have a deployment config. It does not have a security context constraint. It does not have image stream. And that is where I got the idea of extending Kubernetes. Just like you can take the Linux kernel, program it to your requirement, add some more features and ship it as an OS, the same thing is happening with Kubernetes as well. You can take Kubernetes, you can add some extensions onto that, package it in a nice product, and you can sell it to the world. This is one of the things which OpenShift does. And OpenShift unique selling point is it targets not the application, architects, not just architects, but developers. It makes developers' life also very easy. And the reason why I think OpenShift is an enabler of DevOps, you build it, you run it. That methodology itself is DevOps. And OpenShift lets you do it because, see, if I'm a Java developer, I may be very good with Java, but I might not know how to put my applications into a container because it's not that simple. We say containers has your application, but who put it there? How do I get my application into the container? And see, this is why they are still booming right now. DevOps has a very high demand in jobs. If you look to the Western market, not just India, I think I remember yesterday I got a message from one of the recruiters. There's a company, I would not name that, but they were just 2 years old. Okay, that's a startup, and they were looking for a DevOps engineer. This is for our candidates, just to let them know how the market is struggling for DevOps engineers. There are so many DevOps engineers, but there are very less good DevOps engineers. And the reason why the salaries are so high for DevOps engineers is it's not just about one tool, it's about the process, the thought process that you have to put in. It's about a long list of technologies you have to know and being able to point and integrate which one goes where. That's also very important. So they were like only 2 years old company, and they were ready to pay per annum 35 lakhs for a DevOps engineer. Just a 2-year-old company. And companies also make a lot of money from DevOps and consulting. The reason why, because there's a shortage of skills. We always, we talk about this every day over the call. We're like, Vatsal, I cannot find good people. There are DevOps engineers, we get the resumes, but it's not good there. So what I'm saying is, you might be a brilliant developer, Node.js, Java, Go, PHP, Python, but you may not know how to put an application into a container, how to package that into an image, how to authenticate yourself to a registry, how to get that to a Kubernetes environment, and how to scale it up. So you are only doing the dev part of that DevOps profession. And on the same side, ops people, they don't know as much development as a developer really does. So they are not doing the dev side of it. Though still, DevOps is not, it's not come together in a broader perspective. Yes, some people can do it because they might have an interest into it. Some people are still struggling to that. And that is where OpenShift comes into the picture. That, hey, okay, XYZ developer, you want to develop your application. You have built it. You want to go to DevOps. You want to work with DevOps, right? You want to implement it. All right. Just give me your source code and I will build it for you. I will put that into a container image. I will do all the tests that you want me to do. I will deploy an application and you have your application running. So you build it, you deploy it. I'm just a medium for that. And that is why OpenShift is a enabler of DevOps. We call it this way. So one of the unique selling points of it is it lets you build and deploy the application directly from a console for your most popular programming languages such as Python, PHP, Ruby, Runtime, Java. And also, if it doesn't have the support for those languages, it lets you give your custom logic of how do you build certain runtime, how do you deploy that. It is very, very extensible as well. So they allow you to accelerate your deployment for the application, building, deployment. That's what OpenShift is. And this is an end-to-end automation. OpenShift has a built-in support for CI/CD pipeline. That's exactly what's happening, right? You get your commit from that Bitbucket repository or GitHub repository, you build it, you test it, and you deploy that. That's exactly what a bare minimum CI/CD pipeline does. And there may be many steps to it, but that is
thanks to S2I.
Yeah, thanks to S2I. A developer can easily deploy their applications to containers now.
Right. Otherwise, there was always overhead that developers should know this container building process, and they should know how to write the Docker file and all those things they need to understand, right? Earlier, they are only focused on writing the code, but then later on, when these tools came into the picture, the entire focus of writing the code has been changed to how they are going to build that and how they are going to run it, right? So that's where those specific additional dependency will be completely removed by this OpenShift, because again, compared to learning code, learning the or getting understanding this UI is quite easy, and specifically with OpenShift environment, everything is easy. Just click on the add option, select the specific image, and then just provide the location where exactly your code is, and that's all. Just click on the create and it will deploy the applications for you, right? So that is, again, OpenShift is something eye-catching feature, we can say. Next slide, please. So when you are talking about OpenShift, you have also mentioned DevOps word multiple times, right? And as we know that DevOps is something which is always and always, whenever we are talking about the container world or orchestration world, always DevOps should be there. Because if you ask me what exactly the DevOps is, how you define the DevOps, then I can simply define it in a 3 specific statement. And I could say that that is basically a culture where you are going to collaborate, right? So culture of collaboration, kind of a word I can use to explain that. The main idea behind this particular DevOps term is to eliminate specifically a barrier between the development and the operations teams, which we have seen a lot, right, initially. Second thing I can see, maximizing a kind of a automation, where we should have a way where we are keep on automating things, also very frequent, and there should be a specific response from that automation. Let it get failed. So generally we have also seen a one specific term, fail fast, right? So keep failing. You should have the automation in place, which will go ahead. You can make your changes, and then let's go ahead and do that automation again, let the code run, and then build it, right? And as and when you get to know about this particular failures, you will go ahead and make a changes into your code, and then you are going to now basically again continuously improvement, automation, and the another word which I was talking about is collaboration. These are the 3 words are a major keyword of the DevOps terminology, right? And in fact, there are what is happening multiple times. I'm doing a lot of interviews for the DevOps profile, right? There are a lot of students.
Is for all of our attendees right now.
Right.
It's job-oriented stuff that we're going to talk about.
So when I do a lot of interviews for the DevOps profile, they have no idea what DevOps is. But what is their end goal? They wanted to become a DevOps engineer. They want to work as a DevOps engineer. That is not how it works, right? Recently, if you remember, Prodivance has hosted that TL500 event, right? So as you know, and you are one of the person who is managing our big bank. So we have most of our customers coming from the finance sector, right? And their data and their the way they are running the workload, which is very critical for them. And when specifically they are adopting a solutions like OpenShift and the other solutions like a VM Tanzu or maybe something else, obviously there should be some sort of a process. So that TL500 is something where all the leaders from the number of different banks came on the one stage, and where that's where they learned how they can implement the culture where you are going to practice all those things, what is the proper way of implementing this culture, how you can collaborate, how you can use the continuous integration, continuous deployment, and continuous development, and all of these things. So that is very important, right? So it's not just kind of a thing where you are going to become a DevOps engineer over the night. It's a process. You need to change your mindset. You need to change your thought process. And once you change it, then you will start thinking about or when you change all of this, your mind will start working towards the DevOps way. That's how the DevOps work. Next slide, please. So as part of this DevOps culture, there are three key terminology which we are keep on using. So would you like to explain about the continuous integrations and all of that three terms, please?
Yeah, sure. So it's always on the screen, when we're talking about it. Continuous integration is you build your application multiple times. See, what used to happen before is if I'm a developer and I'm doing 100 commits in a day, first of all, having a shared Git repository is very important, right, in these days.
Right.
Because all of these tools, which is maybe you're talking about Jenkins, you're talking about OpenShift Container Platform, you're talking about any other one, they integrate very well from your Bitbucket repositories because infrastructure as code. And usually what used to happen before is if I'm building something, I will have 100 commits in a day. And in the evening, I have my build cycle. So I only build in like 7 p.m. I start the build and it is failing. Now, I do not know at that point of time that out of these 100 commits that I have done in a day, which one is introducing that failure? Which change has introduced that failure? And then going back to the 100 commits, it can become very difficult. Take an example. When you make a house for yourself, it's a very big task to make a house. And you go there every day. You watch it every day. You talk to the people who are making your house and you're like, hey, you know what? This thing is not right. I want you to not do that. And if you catch that problem at a very early stage, it's easier to roll back. They might be just making a pillar in a wrong place and you don't want that pillar there. So if once it's set, it can become very difficult to get that removed. But if it's not set because it's only a very small change right now, it's easier to get rid of it. It's easier to change it if you want. So continuous integration is exactly what you do when you're building a house. You go there every day, you see what's happening. If something is going wrong, you change it. But at least you're constantly watching what has been done. Rather than, you tell the people, okay, you make my house, I'll come once every month, first of the month, and then I will see what the problems are. That's going to be a very big problem. If something is going wrong, you can't just remove the whole house and fix it. You can't do that.
Right. And meanwhile, if you are coming after the 1 month, there will be a lot of things which is already built it. Right?
Which is already built, exactly.
Right. So then you need to do a lot of correction. But if you have a very small change, then it will be very easy for us to fix as well. And again, you have a good mentor in one of your environment where you are learning these things a lot, right? Where you are making a small changes and how to make those changes.
Absolutely. I really owe everything to him. So the point that I'm making is if you have a problem in your basement while you're making your house and you come 1 month after, it's already, you have the roof now, you can't make the changes in the basement anymore. You can't just do that. It's set already. So continuous integration is each time a developer commits some changes, that change is followed by an automated build. So right then and there that okay, till this level the code is fine, or till this level the code is not fine. You will know once the build is failure or successful. And that is continuous integration is. You release, you build frequently in a day, as many times as you commit, you do a build of it, and you are able to see that build, if it's working fine or not. Look at the logs of that build. If it is failing, why? What needs to be changed? And you do that. You commit again. You see the build. It will be successful. That means, yep, my application till this point in time is working. So that is what a continuous integration is.
Next slide, please, Tinker.
So
Yes. Yes,
there are two things actually: continuous delivery and continuous deployment. So building that multiple times in a day is continuous integration. Okay. Continuous deployment is you take that artifact which has been built. Okay. That was built from the continuous integration. Maybe it's a jar file, maybe it is a exe file, maybe it is a Docker image. Your artifact, whichever has been built, you take that and you run that and you deploy and you do the test release onto it. So you do the live simulation tests as would have been done in the production environment to see if any unforeseen errors may have come up during the unit tests or before that you did with the continuous integration. So that is a part of continuous deployment. And this also happens several times in a day, like the UAT environment. Yeah, the testing environment that you deploy that to. Because when it comes to production, you have to be free of errors. You cannot risk your pod environment.
Right. And unless you don't get to know what is the problem, you won't be able to solve it, right? And that is always good that you will get to know about your problems as soon as possible. So you can fix it and you can redeploy.
It's able to eradicate them at a very early stage before they become a really, really big issue.
Right. Next slide, please. So when we talk, when we discussed about all this continuous integration and continuous deployment and all, but when we are building all of this, or when we are trying to develop our codes, there are also a lot of things which we require to take care. And if we talk about a lot of developers, they are just developing it, right? So they might be not aware about all these standard functions, how exactly they are working. So if we talk about this, don't repeat yourself, which is basically a try way, where what we will do is basically we will try to make our code very simpler, and we will not use unnecessarily sort of a patterns which will make your code more and more complex, right? So such things you need to take care when you are building your code. Apart from that, a simple way is keep it simple, stupid. That is what the term is, which is for KISS. So simplicity should be the goal of your end development, right? So when you are building your application, just assume that I might be able to create a code which nobody can understand. However, I should also be able to, your approach should be like that. Whenever I'm building anything, I should make sure that there is no unnecessarily complexity. Plus, anybody who is looking at that particular code, that should be easily understood by that particular user as well. So no need to create a basically unnecessary complexity within your code and unnecessarily using a lot of logics, which is not required actually to produce the specific work. Then you aren't gonna need it. That is another term, which is Yagni, we can say. So again, this is a kind of another methodology which used in terms of avoiding unnecessary development. I might have hundreds of ways to building a one simple application. Which one you choose, that matters a lot. Sometimes what I will do is I just need to print hello. I could be able to write a one single line of code to print hello, or I could be able to write a 10 line of code just to print hello. So you need to basically ensure that the way you are writing a code should be a very, very easy, and you're not going to keep on using the unnecessary things inside your code. Plus, there is another methodology, which is inversion control, that is used multiple times, we can say. So these are the kind of a terminology which we should keep in our mind when we are building or when we are basically developing our application. And I'm sure that a lot of developers might not be aware about all those things, right, in current world. So if you are going to adopt this DevOps culture, then you should also start practicing with all these basic developing skills, right? Yes, Shubham. Anything from your
Vatsal,
side?
like I have a question for you at this point of time. Do you think there is development in DevOps? Do we code?
Sorry,
Is coding required in DevOps?
not 100%, I could say. But obviously, there are certain level of code. Even building the pipeline is what? Pipeline building is again a part of the code only, right?
Hmm.
So how you, why that question?
The reason why that question is because a lot of people have this conception that if I am going to DevOps, I will be not required to code. I will be only required to work on these given tools and I should be good to go. That is,
I think then you might have met another side of people. I always meet a kind of a people where I wanted to become a DevOps engineer, and do I really need to code? That's what the kind of a question I get.
yeah, that's exactly what I'm talking about.
Right.
That I don't like coding. Can I be a DevOps engineer? Let's put it this way, and there are people who will say, yes, you can. There are people who will say, this is for the audience itself. If you are aspiring to be a DevOps engineer, or you already are, and you can assess yourself if you think, you are good with programming or not. Should you be a DevOps engineer or not in this case? I think it's absolutely important to know the basics of one programming language. It is absolutely critical to know to a certain extent. I'm not saying you have to go do the competitive programming in Python. I'm not saying go to lead code and start solving those problems. No, that is not needed. Understand what DevOps is doing. Okay, understand the code, the application is already written by some developer. So you're not the one writing the actual code, the business logic, but when applications are talking from one place to the other, how are they getting to know where the applications are running? Inside that code, has that somewhere been hard coded or not? Is it getting it from an environment variable? So if Python is there, how does Python pick an information from environment variable? What is the environment variable set? How does it connect to? This is not about a coding, but you as a DevOps engineer, you deploy some application, it is failing. You can't always blame the infrastructure. It might be a bad code inside. So unless you know that sort of coding, Node might have different way of reading the environment variable. It might have different ways of setting HTTP header. Python might have different ways of doing it, but at least one programming language is extremely important if you want to go ahead in DevOps. Apart from that, if not this, you can still call yourself as a DevOps engineer, but technically you are just an ops engineer. If something comes to dev, you'll always ask for the developer. This is failing. It's not my job. Please do that. So there's not much difference between you and an ops engineer if you're not able to do the dev part of it. And when you are working with DevOps engineer, we don't write code for applications. We write code for automation. Right? So if I could suggest something to our audiences, you should at least know Python and know only two things with that. First, how to make an API call to a service. That includes authentication. That includes HTTP methods. That include your bearer tokens, OAuth, OpenID Connect. How do you get the tokens to it? Second, how do you pass JSON output? Because once you're able to do at least this thing, you will be able to make very good use of your programming language. For example, if I say there's an OpenShift container platform, I want you to tell me all of the persistent volumes which are using a particular storage class. Let's say, remember this was one of the cases we were talking about before. So if I wanted to do this with programming, I want to automate that. I can do this with Ansible. I can do this with Python. Doesn't matter. But if you know Python, because it's still a very widely accepted programming language, you will be very, very standing out of the people who only can do this with Ansible. Because there are some things Ansible cannot do, but Python can. That is as a programming language. Ansible still has some limitations to it. Not in
Correct.
this use case, but still, you might come across certain scenarios. And it is the
Right.
code that is running inside the container. It is the programming language that runs inside the container, not Ansible. So knowing that code is also very important. Being able to understand the code, as long as you're able to do this thing that I've just said, you still should be able to stand aside from a lot of people who call themselves as a DevOps engineer.
Right. That is again a good point. So I think if we will do around about 20 webinars like this, then the audience will become a champion, as you are sharing the crux of productions, what you need and what you don't need. Okay, so I think we had discussed a lot of things about the DevOps, and but still, I think you should go ahead with one kind of a small demo, which will talk about how exactly these basic things are working. And what we will do is, I think again we are done with the timing, but still let's do it for the 10-15 minutes. And the next time when we come again on the stage, I think we will come up with a kind of a full-fledged plan where we will go ahead and deploy the entire CI/CD pipeline, how we can create it, how we can pass the argument and approval kind of a codes, and then we will deploy it. That kind of a webinar we will do next time.
Right. So
Right.
if I can share my screen, I want to show a demo that I have prepared for all of us. All right, I can share it now. So it's a very, very simple, it's a very simple demo that I have made for us. Let me just stop sharing that for a while and open what I need to open. All right, so here it is. So I'm using a GitHub repository, which is public from Red Hat itself.
We can't see your screen.
I'm just going to share it now.
Achha.
So what I'm saying is I'm using this public repository from Red Hat, which is do288-apps. I'll put a link of this in the chat itself. Should in case you ever need to, should in case you ever need to go, I'll just put it for everyone. Should in case you ever need to have some codes for your testing, you can use that particular one. I'm going to use Hello World Nginx. So this is a very simple application, which is just index.html that says hello world from Nginx. Let's say you have some sort of coding. I'm just using HTML. You can use Node.js, you can use Python, Perl, Java. For the sake of easiness, I'm just using Node.js at the moment. And I am already logged in to an OpenShift cluster. I can show you OC status, and this shows me that this is my server.
Increase your font a little bit, please.
Sure, let me just do that. Okay, is that visible now?
Yes, better.
Okay. So what I was saying is, you can see here, I have OC status, and this shows me that I'm logged in right now. I can do a new project. Now, this is not going to be a very full-fledged class on OpenShift, but a project is like a subfolder that you create, which holds multiple applications that you have made. Okay, so I'm going to make a project called DevOps Seminar, Webinar, whatever you want to call this name. And then I can use a command called OC new app. The OC new app is a command that OpenShift it's like a first gateway for you. After you log in, it's like a first gateway for you to deploy an application. Now, right now, my application is just a file over GitHub. And I want to build an application off of it. I want to do some sort of lower level testing. And I want to deploy that as well. All right, that is what I want to do. So I could say OC new app, name of my application is Hello Nginx. And what is the GitHub repository? And within that, from what directory I want to build my application, which is Hello World Nginx. That is something exactly what I just showed you. Hello World Nginx. If you want to see the Docker file, if you know Docker file, it's available. Now, should I build it? You will see a lot of output. So what OpenShift is doing in the background for you is it is building your source code, combining that with an existing image somewhere. See, you are running HTML. Your code is HTML. Your code will require a web server, right? So OpenShift does it in this way. This is S2I. OpenShift says, okay, your code is HTML or PHP or whatever. It requires a web server. I already have made an image which has web server. I'll take both of them, combine them together. I'll build it for you. And you can look on the pods using OC get pods and see the build is going on right now. And you can look on the logs of that. OC logs and -f, you see, this was the actual building log of how your application was built. We are not going to go into a detail of this. This is a very elaborate process. But in the end, what you get is OC get pods. You have your application running. And if you look on the logs of this application pod, at the moment, it doesn't have any logs. So it might be possible your application is not producing any logs. But if you get OC get all, you will see something. See, let me help you with that. The first thing you see is a build. So this build specifies a particular building of your application source code. The many times you start a new build, from the build config. The build config defines how to build an application. What is the Git repository? What are the credentials for that Git repository? What is the source code language written in? What is the image I want to use to build your application? All of that. All right. From that build config, we start a build. And that is defined by this build out. Okay. You also have a deployment, which is going to deploy your application. So OpenShift took your application source code, build it, and then once that image is built, it pushes that to an internal registry and deploys it from there. So a whole CI/CD pipeline, right, in build of OpenShift is there for you. It's available for you to work with. Now, I need to test this application. So for that, I can expose it to the outside world. Internally, we have a service, but outside we have a route that is created. And I can expose that using a command OC expose service hello-nginx. That lets me create a route which is publicly available. And this is the route that you all can actually use as well. So Vatsal, if you just go to this route, you will be definitely seeing my application. And if I just curl it out from here, you see hello world from Nginx, which is exactly my application. And this is deployed right now on OpenShift Container Platform. If I now go back to my application, GitHub, make some changes, rebuild again, everything will happen. And in a couple of seconds only, my application will be live and up and running on a particular OpenShift Container Platform, right? So that is the beauty of S2I, of source to image that we have. The name suggests it, source to image. And that image is deployed by OpenShift Container Platform for you. You can scale up, scale down to the number of pods that you have. Let me show you right now. I have only one instance of this front end. But say a lot of traffic starts coming in. I want to scale out on that. I can do OC scale command, replica to 10 for a deployment whose name is hello Nginx. And now you see you have 10 new OS being created. And how fast is it? It only took 5 seconds for all of the applications to come alive. And how this is something we need when we are working with the big billion days and all that, where a lot of traffic starts flowing in, just like that. So OpenShift lets you be having a self-service portal. where you can go to build an application, deploy them, and scale up and scale down on demand, like what I did, or on demand or manual. Manual is what I did. So yeah, that is something which I wanted to like show. It also lets you see how many pods are using how much memory and CPU. So monitoring is also possible right out of the box in OpenShift Container Platform. So my particular pod, Hello Nginx, is using 2 millicores of CPU and 31 megabytes of memory. Now for running a 31 megabytes of memory application, I should not be giving 4 gigabytes of memory. I should not give 30 gigabytes of storage. That's what lightweight containers are.
That's what the beauty of container, and that is again the way we have seen the automation, the way it get deployed with OpenShift in a fully automated way. I think that is amazing, right? Say if somebody has already worked on Kubernetes environment, then they know the pain of creating all the file manually and then run it and then go ahead and create the service out of it, change the type, or create the Nginx controller, or a lot of manual things are there, right? But with OpenShift environment, again, yes, there are a lot of control should be there. So that control we can manually, put it into this particular entire workflow. But compared to other things, OpenShift is very easy and automated kind of a solution to deploy and run and manage your application, no matter what type of applications you have, right? So yes, Shubham. So thanks for that demo. I think we are already 17 minutes ahead of our time. So what do you think, whom we should give that echo dot from our participant?
Echo dot, yes, that's a good thing. That's a good question. So guys, we have a question, we have like a challenge for you. So I think if everybody in the attendees, we have got 4 people. So we're just going to talk to these 4 people anyway. Hiren, Jitendra, Puneet, and Suraj. What I just did right now.
There are others also on YouTube. So to everyone, basically.
Okay. To everyone, basically. So what I've, yep, hi. I just said your name, Puneet. So what I'm saying is, to everyone that I just showed you a demo, okay, I want you to do the same thing. I want you to spin up an OpenShift container platform. We want you to go and deploy an application of your choice. It could be HTML, Java, PHP, Python. We want to see that you are able to expose that to the outside world. You want to see the output of that application. So basically, we need you to deploy an application on an OpenShift cluster. Second, we want to see the output of OC logs and the pod name, whatever pod you have in your application. Third, we would like to see the output of OC get all. Fourth, we need to see the output of OC get route. And then if it is a web application, we want to see the output of curl command and your route host name. Okay. So that means if you do this, it will tell us you were able to work with OpenShift, you were able to use source to image, and you were able to expose your application to the outside world. And the deadline for this particular task, is till tomorrow. It's tomorrow, 6 p.m. It is on the first come, first serve basis, So the person who sends us this thing first, he will be or she will be eligible for that without any partiality. We would send you an invite, or we would send you rather the link or the coupon for that, whichever will be fit for that Echo device. Okay. It's a very, very easy challenge, and it is a very, very good option or opportunity to get that Echo dot for you.
Right. And you don't also need to go ahead and deploy the OpenShift cluster and all. There was a link which I have shared at developers.redhat.com one. You just click on that link and your cluster will be up and ready, and within 20 minutes, and you will be able to access that cluster for 1 hour. So generally, if we talk about this task is not going to take more than 2 to 3 minutes if you know the structure. If you don't know the structure, then at least you require 30-40 minutes to go here and there to get the solutions, right? So yeah, hope to see some sort of a winners. You are going to get the mail very soon in the next 15-20 minutes.
Can you please share once again the 4 steps?
Yeah, that's why I made that comment that we will share this information over the mail.
To all the participants that we have, we'll be sending this email again to you in about max top an hour, and you will then be able to use it. So the link that I've given you for the developer@redhat.com, you might not see anything, just scroll down. There's a launch button in the right bottom corner, and you will be able to see that there. All right, so guys, we will be sending you then the email for the questions, or the steps rather, the 4 steps. We'll wait for your inputs till tomorrow. Vatsal, where can they send the invite? Where they can send the questions?
Those information will be shared over the mail.
Okay, perfect. All right, we have here as well.
Right. In fact, Snigdha has already posted there. Okay, before we leave, do you guys have any question for us?
Yeah, we have a Q&A session as well. Thank you so much, Hiren. We are glad it was useful for you. And we'll keep on coming up with these webinars. Today, it was just an introduction of containers and, OpenShift. We want to go so deep with you guys on this sessions. We want to go to a very good detail on how do you work with it. So let us know if you have something planned in your mind for us to have in the next sessions, and we will be definitely coming up with those. You can just send your,
so you can also share your expectation over the mail, and it will be much better if you can get some of your friends also on the stage, and we can be able to do a healthy discussion that is much better, right? And give them also opportunity to get some nice goodies again, like the one any of you are going to get, right? So yeah, thanks everyone for giving us your time, and happy Diwali to everyone. Stay safe, enjoy a lot this festival time. And yeah, that's all from my side. Shubham, over to you.
Yep, that's pretty much it, guys. Enjoy, happy Diwali, stay safe, as Vatsal said, just take out some time for this challenge if you have a little bit. And as Vatsal is saying, if you want us to come up with any other particular topic, just let us know in the email that you'll be sending to us. And while one will be getting the echo dot, everyone would be everyone's inputs will be listened, and we will be coming up with those solutions. So with those seminars and webinars on that topic. So let us know, guys. We will send you an email on all of your registered email IDs if you have registered. And good luck with the challenge. We'll probably meet you the next weekend or whenever we have a new plan.
Thank you. Bye-bye.
Thank you, everyone. Bye-bye.